So continuing with the 7.1 lesson, let's take a look at example 3. F of x is x to the fifth plus x minus 18. First, we're asked to prove that f has an inverse. The easiest way to do that is to take the derivative. The derivative we could quickly see is 5x to the fourth plus 1. By the way, this is always going to be greater than 0. So f is strictly increasing, therefore f is 1 to 1 and has an inverse. So we don't have to graph this function and do a horizontal line test. This is actually a more effective way. But finding the inverse would be painstaking. And imagine what would happen if we were to change x and y, switch x and y, and try to solve for y. There's no way you're going to be able to do that. So we are asked to find the slope of a tangent line to G at the point negative 16, 1, and that's not going to be able to be done by first solving for that inverse and then simply plugging negative 16 in. Instead, what I'd really like to make sure that you know is that you want to identify which points lie on your function and on your inverse function. Negative 16, 1 would have to lie on our g, which happens to be the inverse of f. Another point lies on f then. And the whole heart of working through inverses is that x and y switch. So we'd have 1 common negative 16 lies on f. I guess what I want to point out, though, is that g prime of b equals 1 over f prime of a. If I were asked to find g prime of negative 16, you plug in negative 16 into the derivative of g, I could do that most easily by saying 1 over f prime of 1. Very important to know that these x values are different. They are symmetric points. They are points that are reflected over the line y equals x, of course. But now I'm able to get this tangent line slope very easily without too much work. And 5 times 1 to the fourth plus 1, well, that's just simply 1/6. That's what our derivative, in fact, is going to yield. Very, very similar problem for number 4. Let's prove that we do have an inverse as well. You can take f prime. F prime would be 5 x to the fourth plus 9 x squared plus 2. And of course, we're greater than 0. So f is 1 to 1 and has an inverse. So that's looking very, very encouraging. Once again, you would not be able to find that inverse very easily. But they want you to find the slope of f inverse of x at the point 5, 1. We could call g f inverse more easily. 5, 1 lies on g. That means another point lies on f. And that point would be 1, 5. So g prime of 5, that's the slope of the tangent line when your x value is 5. It's going to be 1 over f prime of 1. So I'll get 1 over, you can see that f prime is right here. It's 5 times 1 to the fourth plus 9 times 1 squared plus 2. And really this is 5 plus 9 plus 2 down below. That would yield 16 in that denominator. So g prime of 5 is just simply 1/16. The next problem is an AP question. And I do want to tell you it's a tabular problem. They're telling you that f and g are inverses, yet they're only giving us information about function f. And from the very beginning, this might seem to be a strange question. It says, find g of 6. Well, 6 is an x value. We always see that in function notation. So I can say 6 comma something lies on g. Something comma 6 then lies on f. In other words, 6 is the y value. I hope we can see pretty quickly from the table that we'd have 4 comma 6 lying on f. That means we have 6 comma 4 lying on g. So what is g of 6? G of 6 would simply be a 4. The next problem we can do, just as well. G prime of 4. Well, let's begin to think about this. 4 comma something lies on G. That means something comma 4 lies on F. And it's a different point. I hope you can see from the table that 3 comma 4 lies on F. That means 4 comma 3 lies on G. I have no information directly on G, but from the problems we've just been doing, G prime of 4 would be 1 over F prime of 3. Now, F prime of 3, I want to point out to you via the table, is given to you. And it's actually 5. So plain and simply, the answer is 1/5. Part C, F of G of 8, I think sometimes kids will hit the panic button and very quickly notice that there is no 8 in this table whatsoever. This is done deliberately. A little review, and you can see this at the beginning of our first video. F of F inverse of x is always going to be x. We could always say F of G of x. If G is the inverse, would be x. Similarly, G of F of x should always equal x. With that being said, our final answer is simply 8, and we're done. One final problem. Let's look at number 6. A particle moves along the x-axis, so its position is given right here. X of t is inverse tangent of t. Find the velocity. Well, immediately, I'm sure kids will say, well, the velocity function is just the derivative of the position function. The problem is, I'm asked to take this derivative of inverse tangent when t is equal to 1. So this is really a very different type of problem. We don't have information on how to find inverse tangent just yet. We will later in the chapter. But here we have a question. 1 comma something will have to lie, or lies, on G. Or we could call it x of t. Why am I calling it G? G is normally the inverse function, and I see this as inverse tangent. We just as well could have called this f, and that's fine. But by the way, this is a little different. If I were to plug in 1 into inverse tangent, hopefully we have enough background with our inverse tangent to say, well, the inverse tangent of 1 is pi over 4. You're really saying what angle will come out, what angle gives us a tangent value of 1? The answer is pi over 4. Well, that means that pi over 4 comma 1 lies on f, and f would be the inverse function as well. It's the original function. You could call it tangent. So right now, I might not have a formula on how to take the derivative of inverse tangent. But rest assured, if I found g prime of 1, that would be 1 over f prime of pi over 4. And by the way, if f is tangent, f prime is secant squared. So really, I've got 1 over secant squared of pi over 4. Real quickly, just some friendly trig review. The cosine of pi over 4, yeah, it's root 2 over 2, but how about we look at that as 1 over root 2? And then the secant of pi over 4 would just be radical 2 itself. So this really becomes 1 over radical 2 squared. And radical 2 squared is just going to get you a 2. Final answer is just 1/2.